So now we're going into our fourth question of the day. Guys, very, very important kind of question. So make sure you pay attention and work through it with me. It says, given that 2 cos of x is equal to 3 tan of x. Firstly, we need to show that the equation can be written as 2 sine squared of x plus 3 sine of x minus 2 equals 0. Okay, guys, you should know immediately that this is a quadratic trinomial and it can be factorized. But how do we get this expression into that form? So let's start manipulating it. We know firstly, 2 cos of x, we can't really do much to. Okay, 3 tan of x, same as saying 3 sine of x over cos of x. Okay, tan is equal to sine over cos. Okay, very important. So now, if we want to try and manipulate this even further, okay, that cos of x in the denominator is kind of making things look a bit x. So let's multiply both sides by that cos of x. So get 2 cos squared x is equal to 3 sine x. Hope everyone is following that. Okay. Now, they give you a hint. We need to show that something is equal to 0. So we need to get things to the other side. So if I subtract 3 sine of x from both sides, I get it equal to 0. Okay, so now, what is missing from what we're trying to get it to? Okay, we've got our 3 sine of x. We need to try and get everything else in terms of sine of x. Cos squared of x, guys. Remember, cos squared plus sine squared is 1. So, cos squared is equal to 1 minus sine squared. Minus 3 sine x equal to 0. So now if I multiply out, 2 times 1 is 2. I'm going to put that at the end there to try and get it in conventional format. So remember, distributive law, those two are going to give me 2. And then the second term, negative 2 sine squared x. And then that last thing, minus 3 sine squared x. Okay. But it says that our leading term needs to be positive. So if I divide through by a negative, I'm going to get 2 sine squared of x plus 3 sine x minus 2 is equal to 0. And that is exactly what we needed to get it into the form of. Okay. So question 2 says, determine the general solution of x if 2 cos of x is equal to 3 tan of x. So we've just manipulated this to be written as 2 sine squared of x plus 3 sine of x minus 2 equals 0. These are one and the same thing, okay? So, as with any quadratic trinomial, if you're trying to solve it, you factorize. So, we know we're going to have 2 sine of x in one bracket and sine of x in the other bracket. Because remember, we're trying to get the factors that will multiply to that 2 sine squared of x. Okay, now we know we're going to have factors of 2 as the last term in those brackets. So 2 sine of x times 2 gives me 4 sine of x. Okay, and we're trying to get to 3. So I know that that's going to be positive and that's going to be negative. So 2 sine of x is equal to 1, which means that sine of x is equal to a half. That's our first thing. Okay. Second bracket, sine of x is equal to negative 2. That's the second bracket. Now you guys should know our sine graph does that. Okay. And it carries on doing that. This highest peak that it ever reaches, or the lowest peak, will only ever be 1 and negative 1. Sine of x cannot equal negative 2, so this is not a possibility. You must write that in there. Okay, so over here, sine of x is equal to a half. You should know your special angles, but if you don't, you press shift, sine, 1 over 2, and you get that x is equal to 30 degrees plus k180. Remember, the sine graph repeats every 180 degrees. And this k is an element of the integers is very, very, very important. Okay, but remember, guys, there are 2 places where sine is positive. If our cast diagram goes like this, we've covered this quadrant. 30 degrees sits in the first quadrant, but sine is also positive in the second quadrant, which means x is equal to 180 degrees minus 30 degrees, because that is our second quadrant. Okay, which means that x is equal to 150 degrees plus k 180, and k is an element of the integers. Okay, so you have to have this line and you have to have that line. There are always two solutions for a sine graph. Okay. And now it says, hence, determine two values, very important, of y if y sits between 144 degrees and 216 degrees. Okay, so that means we're looking for a specific solution. That are solutions of 2 cos of 5y is equal to 3 tan of 5y. So what you guys need to notice is that when we're dealing with this, we had just x's in our equation. Now we have the exact same equation, but the x has been replaced with 5y. So if you look over here, it's exactly the same equation. We found the general solution. Okay? We found that x is equal to 30 degrees plus k 180, and k is an element of the integers, or x is equal to 150 degrees plus k 180, and k is an element of the integers. Okay, but they've said now, instead of working with x, we are working with 5y. So instead of using that general solution, you now need to go and substitute 5y in there. So we have 5y is equal to 30 degrees plus k 180, and k is an element of the integers. Or, I'm going to leave some space because we need to work, or 5y is equal to that second solution, 150 degrees plus k 180. K is an element of the integers. Okay, so we found our general solution over here. But we are not working with the general solution, we are working with 5y. Okay, so now we need to go and manipulate. To get down to y, because we're trying to find y, we have to divide everything by 5. Every single piece. Okay, so that means that y is equal to 30 degrees divided by 5, which is 60, plus k. You even divide that k by 5. Okay, so 180 divided by 5, I'm going to be lazy and use the calculator. It's going to give me 36 degrees. Okay, k is still an element of the integers. And then this one, divide everything by 5. So 150 divided by 5 is 30 degrees, plus 180 divided by 5, which we found is 36 degrees. Okay, k is an element of the integers. So we have found the general solution when we substituted 5y in. But, guys, they gave us very specifically, when they give you an interval, you have to find only the angles that lie in that interval. So between 144 and 260. Okay, that is our interval. So from this solution here, if I take 6 degrees and I add 36, I get 42. Does not sit in that interval. Okay, yeah, try and move. My calculator's not moving. Okay, that's fine. If I add another 36 degrees, I get 78, not in the interval. So you keep adding 36 until you get into this interval over here. So, still not there, so we need to keep adding 36. Aha, 150. So the first one is 150 degrees. That is a specific angle in that interval. So that will give me 150 degrees. The second angle, because they say give two values of y. Second one comes from the second solution. So y is equal to 30 degrees plus 36. So 30 plus 36. Is it in that interval? No. So we add another 36. In the interval? No. Not yet. in the interval 174 degrees. And those are our two answers. Okay, so guys, this is going to be a massive question in your test. There's a lot of working out. We have one last question. I'm going to try and power through. We might run out of time though, guys. Okay, so it says, consider the graph of g of x is equal to -4 cos of x plus 30 degrees. Firstly, it says, write down the maximum value of g of x. So, what you need to do is compare this to the mother graph, okay? So, you know that your cos graph, at 0, it starts at 1, and then it does that, okay? And it does the same thing on the other side. So, we know that this maximum value here is only ever going to be 1. Of the mother graph, this is cos of x, okay? This thing here, let me erase this. This situation means that I'm shifting the graph horizontally. It's going to move, okay? It has nothing to do with the maximum value. Does not affect the max value. Okay, so that you don't need to worry about. We're dealing with the maximum value only, okay? So what you need to understand is that this value is going to affect it. So if I have the mother graph and we have a maximum value of 1 and a minimum value of -1, if I multiply that graph by -4, I hope you guys agree with me, that this -1 multiplied by -4 is going to take the graph all the way up to 4. And then this value multiplied by -1 is going to take it down to -4. So the graph is going to reach peaks and pits of 4 and -4. So the maximum value is 4. Okay, very important. Secondly, it says determine the range of g of x plus 1. So, looky here, we've established in this graph, because we've multiplied it by -4, the graph is going to, it'll have shifted, so it's going to look something like that. Okay, and we've just determined that that max value is 4, minimum value is -4. Okay, now if I'm adding 1, it means it shifts the graph up 1. So it's going to shift up. Okay, so that means that that minimum value over there is -3, and this maximum value is 5. So the range is the distance between those two. So the range, you say y is an element of, it is going to touch both of these values, so -3 and 5. Otherwise, if you wanted to use interval notation, you could say -3 less than or equal to y less than or equal to 5. But very important, guys, square brackets because that graph does actually touch that value, and equal to because the graph does touch the value. And then last question, it says the graph of g is shifted 60 degrees to the left and then reflected about the x-axis. Guys, I do not have time to go through this, but remember, when you have a graph of x, if I want to shift to the left, I say x plus 60. Okay, this sign in the brackets there is always opposite to the direction that you're going. So you need to take your original graph. We don't have cos of x. We have cos of x plus 30. You need to go and add another 60 and sort that out. Reflection about the x-axis means that you make the whole thing negative. So you're going to have to implement a negative over there. Then it says in its simplest form, guys, I know for a fact that this is going to come out as cos of, I think it was 90 degrees plus x, or x plus 90. So in its simplest form is going to be negative sine of something or other, because cos of 90 plus x is negative sine. Okay, don't have time to go through that. Go and check out the memos online. They are online, guys. Okay, so that brings this final show of the week to a close.